Alright, so this problem says there's a clown rocking in a rocking chair in the dark, super creepy. So I went ahead and I drew the motion of his nose, and his nose is moving out and then back to its original position, and that's going to be your 0.42 meters. The amplitude is just the distance that it went from the starting point to its furthest point out. So basically just one movement of that arc. I put it in red there to illustrate the amplitude. Alright, for part B, it asks you to find the period of that motion. So in order to do that, you're going to set up period is equal to the time over the wave. And for our purposes, that just means how many times that clown was rocking. So the time was 1 minute, and he rocked in his chair 30 times in the course of a minute. And so we're going to convert our minute to 60 seconds and then write our 30 times again. And so we're going to have 60 over 30, and that'll end up being 2 seconds for our period, so 2 seconds per wave. Moving on to the next part, it asks you for the frequency. The equation for frequency is just 1 over t. So you're going to take your 2 seconds from above in part B, and that'll give you 0.5 or 1/2 hertz, because the units for frequency are always in hertz. For part D, you're going to bring down our period from above 2 seconds, because the time that it takes doesn't change, and the wave or how many repetitions he didn't change, so that's going to be the same. Frequency is the same thing. Since our period didn't change, our frequency is not going to change. And then for the amplitude, this is a little bit more tricky. You could have it as 0.5 meters, assuming that you would start in the middle of those arcs. What's important here is that you just realize that the amplitude is the distance in one arc of that motion, so from start to the farthest point out.